chapter. So we're going to start off with the big shape again, just like last time, quadrilateral. We made this graphic organizer, or a different version of this graphic organizer, when we had just 4 shapes, okay? 4 special quadrilaterals. We had our parallelogram, our rectangle, our rhombus, and our square. Well, now we added 3 more, so we have to figure out where do these all fit. So we're going to have one branch. This first branch is going to be our parallelogram. Now we know how the parallelogram branch goes. It goes down to rectangle, and on the same level as rectangle, rhombus. And then below that, we have the square, yes.
Wouldn't it technically be polygon and then polygon?
Yes, we could go down further and say we could go higher up above and say polygon to quadrilateral. I'm okay with us starting with quadrilateral because I'm just saying, hey, all of these have that in common. That is the most specific connecting theme all 7 shapes will have. Yeah.
Yeah, because we all scream that's incest.
Our next branch here is going to be trapezoid. Because trapezoid can't be a parallelogram like we talked about earlier. It's separate entirely. And then what's a more specific type of trapezoid?
Isosceles trapezoid.
The isosceles trapezoid. I feel like I said that one weird. It's the isosceles trapezoid. It's a trapezoid, but the legs are congruent. So just like before, when we said, hey, a shape's always the shapes above it, but not necessarily always the shapes below it. So a rectangle is always a parallelogram, but not always a square. Isosceles trapezoid is always a trapezoid, but is a trapezoid always isosceles? No. Okay. And what do we think our third branch is going to be here?
Kite.
Just a kite. And that's actually by itself, it's lonely.
Wait, what is it connected to?
Quadrilateral. So all of these are quadrilaterals. These 7 shapes make up what we call special quadrilaterals. They're quadrilaterals with special things about them. And then we learned each of those special things and documented those on our note cards. We're also going to document that on our next page. Does anyone still need this before I move on to the next page? Okay, a few of us do. That's okay.
My pen ran out of ink.
Oof. This chart is going to be a nice handy place for us to keep everything organized in one spot about our different shapes. You might notice that it's broken down into sides, then angles, and then what? Diagonals. So it's broken down into 3 different categories: sides, angles, diagonals. Sides. Which shapes have all sides congruent?
Yes.
Parallelogram. All of them.
Nope. Yep, square. And one other, rhombus. Those are the only 2 that will always have all sides congruent. Whenever we're marking these, it's always. Okay, it's only the ones that's always true in. What shapes always have both pairs of opposite sides congruent?
The other one.
Rectangle, rhombus, square. That's all I know.
Yeah,
Parallelogram. If you check something for the parallelogram, is it going to be true for a rectangle, rhombus, and square?
Yes.
Yeah. Okay. Which one has exactly one pair of opposite sides are congruent? Trapezoid? And isosceles trapezoid. Kite won't have any parallel lines.
Oh, yeah.
2 pairs of consecutive sides are congruent. 2 pairs of consecutive sides are congruent.
Parallel. Square.
Kite.
Let's go.
The kite specifically has 2 pairs of consecutive sides congruent. Now, technically, a rhombus and a square would fit into that category, but I don't want to write that because then that might get us confused. If that makes sense? So the kite has the 2 pairs of consecutive sides congruent. We can think of that as the sides of the kite, like the left and the right side, so to speak. Both pairs of opposite sides are parallel. Parallelogram. If it's true about a parallelogram. Rectangle, rhombus, square. Those first 4 we learned. Exactly 1 pair of opposite sides are parallel. Isosceles trapezoid and a trapezoid. Not a kite. Kite doesn't have any pair of parallel sides necessarily.
Just think about it.
Oh, I was thinking about congruent.
Yeah, if kites did have a pair of parallel sides, it would then be a trapezoid.
It would be not a kite.
An isosceles kite.
Okay, now we're on to angles. All angles are congruent. All 4 angles are congruent.
Square.
Rectangle and a square. Those are the only 2. If it's a rectangle, it has to be true for the square, right? Both pairs of opposite angles are congruent. A little more broad. Parallelogram. And thus the following 3. Exactly 1 pair of opposite angles are congruent.
Kite.
Kite.
Is all by itself.
Yeah, it has.
Yes.
Stupid kite.
It's always by itself.
I mean, yes, kite is by itself. Last angle 1. 2 pairs of base angles are congruent.
Parallelogram.
Trapezoid only.
No, parallelogram. No.
Isosceles trapezoid only. The trapezoid doesn't have any congruent angles unless it's isosceles, but they do have the leg angles being supplementary. Diagonals. The diagonals are perpendicular.
Rhombus.
Okay, rhombus.
Square.
Square. If it's true for a rhombus, it's true for a square.
Rectangle.
Nope.
No. True one more. Kite.
Kite has fans. Look at that.
Yes. Finally, kite has something else too. Okay. Diagonals are congruent.
Square.
Okay, square and a rectangle. Those are the 2. Oh, actually, one more of them. Isosceles trapezoid. The diagonals bisect each other.
Square.
Okay.
Parallelogram.
Rhombus, parallelogram, wooden rectangle. None of the other 3 though. Those first 4. So we're noticing that those first 4 kind of have a common theme together often. The last 2 will have a common theme pretty often, and then kite's kind of off on its own. And does that kind of match this little flowchart family tree style thing we did? Yeah, it kind of matches with that with our different branches here. Okay. We're not done with the note packet.